The Austin Area Science Festival has been an annual event for more than 40 years. This is the competition each year for the winning science projects from area schools at all grade levels. Over 1,700 students participated in Science Fest this year, and the quality of the exhibits was terrific. The event required over 200 judges, professionals from the City of Austin, private industry, local universities, and the U.S. Armed Forces who volunteered their time. Winners of first, second, and third places advanced to state competitions, while the top 4 Best of Fair winners go on to the international competition held this year in Detroit. At the middle and high school levels, first, second, and third prizes were awarded in 15 science categories, ranging from behavioral science to zoology. In addition, Austin Energy, the City of Austin's electric utility, sponsored a special award for the project that best explored the use of electricity. A number of students chose projects with practical applications to their everyday lives.
I did some background information on my project, and I found out about the radiant heat, and I found that whenever it absorbs it, it's called the black body. I would freeze it for the exact same time, so no ice cube would have an advantage or disadvantage. And I also marked my display stand with a circle, so no beaker would be able to be closer or it'd be farther. And I concluded that the red melted first, and then yellow and green, white, and then coming in blue. I did this project because we just recently built a house, and I wanted to see what color we should paint our walls to keep it the coolest in summer.
I just wanted to see how I could save electricity in my house without having to turn on all the lights and pay for all the expenses that the air conditioning costs. I found out actually that the mirrored pane did the best because if you look at the mirrored pane from a distance or from how far the light was positioned, it actually is a mirror. And the only way you can actually get the data from the probe inside is to put your hand on it to look straight at it. So the mirrored pane actually was a mirror, and it deflected all of the heat's, or in this case, lamps' rays. The double pane came in second because of its just basically having 2 panes and having an insulation in between them, trapping air. And the regular pane did the worst because it just had no properties that were meant to block heat. And it actually had a greenhouse effect where after 24 minutes, it actually went negative because all of it would let the heat go in, but it would trap it in and make it hotter, which actually had a negative result of being able to block heat.
I designed a process for DNA fingerprinting with beef liver and pork kidney and green peas and yellow peas. I did the extraction process, and then I ran it through an electrophoresis gel, which was designed from last year's project. I'm gonna try to develop a process so I can do it with hamburger meat, and then try to find pork contamination in the hamburger meat from different stores.
In my project, I tested recent finds of beta-carotene fighting cancer. I infected a number of plants with cancer and fed some of them beta-carotene solution and some of them tap water to compare their growth rates and see if beta-carotene really does help fight cancer in plants. My results ended up being fairly inconclusive as I did not test for a long enough period of time. However, the symptoms and signs of the cancer did disappear in the plants that were fed beta-carotene.
My project is to build a robot that is capable of moving around, finding this puck, and then taking it to a lighted goal. First I built a prototype, and I had to keep changing it by deciding what type of wheels to use and changing how the light sensor would work. If I could put a light on the ball and the goal and see if it could find both by using a light sensor, which it couldn't. I did this because I got a Lego Mindstorm set, which had all the building pieces that I used about 2 years ago. I decided when the science fair project came up that I wanted to do something on artificial intelligence. So I just built this robot. It had no instructions, so I had to build it myself.
What I wanted to do was I wanted to see if different shapes and types of bridges would affect the efficiencies of toothpick bridges. And the efficiency of a toothpick bridge is how much the bridge can hold over how much the bridge can weigh. And what I did was, my procedures was I would do 12 designs, and then I would place a sheet of wax paper over each design, like this. And then after both sides are dried, I would place toothpicks on the top, roadway, and sides. And then I would place this thing which I made. It's like a cotter pin. And then I would place that in the middle of the roadway, and then I would attach it to this hook, which I would place the weights on here until the bridge would break. And then I recorded the results and found out their efficiencies.
My project is about de-icing roads with salts, and I was going to test that by finding out which salt affects the freezing point of water most and least. Various salts were sodium chloride, magnesium chloride, sodium sulfate, sodium carbonate, potassium chloride, calcium chloride, and sodium iodide. So I'd put 5 grams of each substance into 50 milliliters of water, freeze it, and take it out, and I'd find out the freezing point. I find the freezing point by looking for when the temperature would become stable, which can be found on a phase change diagram. And so like with the increase of energy and increase of temperature, a solid will come up in temperature and become stable at the freezing point. And so after finding the freezing points, then I'd know that like the lower the freezing point, like the more effective the salt is on de-icing roads. I got the idea when I saw like trucks on the roads on on the news, and I wondered, did like the salt have a chemical property that helped melt the ice, or did it like use the friction of the car's tires?
What I did first was I dug a hole that was 22 inches by 3 feet, and I laid the pipes in there. I had a 10-foot pole, and I cut that according to the measurements. 2 of them were about 2 feet, and the other 2 were 3 feet, and they connected. I had a pipe that I put down in the ground so that I could measure the ground temperature. After that, I filled it with sand, and then I put water on it so that it would stay cool. And I put the dirt over it from the hole so that it would stay cooler than it would already. After that, I put the hairdryer on. I used a hairdryer to blow the air through so that it wouldn't be still, so that it would go all the way through. It stabilized at about 100 to 110 degrees. What I found out was that the air going in was had about a 30-degree difference than the air that was coming out. The air that was going in was about 100 degrees to 110, and it'd come out about 70 or 50, which shows that the ground is a good insulator and that it can cool the air. This experiment could also be done backwards. During the winter, I could put air through that's colder, and the ground could heat it up and put it in the house. You could use it like in Texas for an air conditioning system, and it would be a lot less expensive than an air conditioning system or a heating system.
I tested the strength of 3 different brands of bleach. To find the strength of the bleach, you find how much sodium hypochlorite is in the bleach, because that's the active ingredient in it. I do a process called indirect titration, and that's where you find the amount of a chemical in a substance by neutralizing it. And I neutralized it with sodium thiosulfate. So what I did is I turned the sodium hypochlorite in the bleach into iodine by mixing it with hydrochloric acid, potassium iodide, and water. And that turned it into iodine. And then when I titrated it with the sodium thiosulfate in the burette pipe, it turned into a colorless liquid. And that's when the solution was neutralized. And then when I find how much sodium thiosulfate I use in the titration, I can then calculate the concentration of sodium hypochlorite. And that finds the strength of the bleach. Basically, I saw one of the Clorox commercials, and I thought, you know, what would be a way I could actually test this to see if the brand name actually lives up to how it's advertised. And in fact, it did, but it wasn't like totally over the top. So in my further study, I said that I want to do more trials, you know, probably have a more variety of brands, and maybe even test for, you know, different properties of bleach.
The basis of my project is that benthic macroinvertebrates are excellent indicators of water quality, and they're used in the field by water quality experts when chemicals aren't readily available. So what I decided to do was to test and see the effects of household pollutants on these organisms. So I went to a test creek behind John B. Connolly High, which was also conveniently near a housing development, created 4 habitats of my own to look like the creek, and then deposited 20 of each organism in each aquarium, and then proceeded to test 4 different household chemicals on each aquarium: ammonia, bleach, copper, which simulated some battery acid, and zinc, which would simulate fertilizer. Out of all 4 chemicals, the bleach was probably the most hazardous to the aquatic environment because it deoxygenated the water completely. And the conclusion to my project basically was that organisms which live in a slightly polluted environment, the creek outside our school, were able to tolerate pollution more easily than organisms which are found in a cleaner area of creek which have not been exposed to pollution in some time.
The problem is the fact that there are more and more highways being built around neighborhoods and that sort of thing, and highway noise is a major factor in like where people live. So effective barriers can be really good for developers to help sell the houses, and also very nice for the neighborhoods. And what I found out was initially the denser the barrier, the better, because like the transmission loss through it works really well, which is why this site did so well. It's got a hedge and a fence and grass behind and trees behind that. But when you have refraction off the top of a fence and that kind of thing, it makes it worse further back. So like 20 meters back, the hedge was actually the same as an open grassy field, which also means that since an open grassy field is cheaper and obviously easier to do, just leaving a little space between the houses and the road actually would work better. But asphalt's not a good idea. I measured asphalt and I did trees. Trees made it worse because it bounces off the bottom of the tree canopy and that kind of thing. Asphalt, because it's reflective and it reflects the noise back up, it doesn't absorb it. But the grass absorbs, and just distance, it also looks nicer. A hedge or two wouldn't hurt because, I mean, it didn't hurt. It just didn't help. So a nice hedge with some grass in front of it and a good distance from the road is probably the most effective thing. I did this because I met a professor at UT, and she told me like what she was doing with her grad students, and they were doing highway noise, and I thought it sounded really cool. And when I grow up, I'd like to be an engineer or a scientist, and so urban design or civil engineering, something like that is what I think I'd like to do.
Well, I was reading an article in a publication recently that was talking about a impact crater on the Yucatan Peninsula, and I just pretty much took it and ran with it. I examined the fossil record before and after the point of KT impact in an attempt to explain possible theories for the point of KT fracture. If there was an asteroid impact at the point of KT fracture like the theory holds, then you would expect to see certain reductions in certain populations, while things like filter feeders would remain the same. Certain species like ammonoids died out in the later Cretaceous, while corals and other filter feeders remain constant. Most mollusks provide good examples of this KT reduction. Mainly due to mollusks are shell creatures. They provide a great fossil record. They're the most well-documented specimen in the record.
I've been a vegetarian my whole life, and I was curious as to why or if vegetarians and meat eaters have a different oral bacterial concentration in their mouth. So what I did was I had one vegetarian subject and one meat-eating subject, and I inoculated the oral bacteria from their mouth before and after eating either lettuce or turkey. And so I counted those Petri dishes for 7 days, and I displayed, those are the averages of, I used 5 plates per category. And on the graphs, that's the averages, and that's for each plate for the 7 days, the amount. I used the graph paper transparencies to count them as best I could. And I recorded what the bacteria looked like for qualitative data observations. And I took pictures every day of the bacteria. I concluded that vegetarians have less oral bacteria in their mouth before eating anything as opposed to meat eaters. And after eating lettuce, my vegetarian subjects' oral bacteria actually decreased. So the lettuce has a cleansing effect, and I'm guessing that might be due to the fiber in the lettuce, or there might be an enzyme that actually kills the bacteria.
What my project was basically about was stopping mutagens from being produced by a process called NAT that is found in cells such as human cells, animal cells. And because of restrictions, I had to use E. coli, science fair regulated what type of organisms I can use. And what I found was that NAT was inhibited by ibuprofen, and I recorded that by the amount of fluctuation between on how they were able to be sensitive to antibiotics, and I recorded the fluctuation in the kill ring. These are my data, and as you can see, the red, just having creatine in the agar, it was much higher than the one with the 1% or the 0.5% concentration. So in conclusion, I guess it stops mutagens from forming, therefore it reduces the risk or the possibility of cancers forming by alteration of DNA.
Phase 2, it's a continuation from last year. What we did is we tested salsa for the types of bacteria it has in it. We also tested any preventative measures for, that would inhibit the growth of that bacteria, and we tested for acid resistance in the bacteria.
We collected bacteria from restaurants and salsa from the restaurants and salsa from the grocery store and fresh products and canned tomato sauce.
We did a series of tests that would tell us traits of the bacteria, and then we compiled the results from those tests to use to identify the bacteria. And then we went on to test the bacteria on different pH levels to test for the acid resistance. And we tested 3 different additives that could be added to the salsa or used to clean vegetables.
Which were vitamin C, hydrogen peroxide, and lactobacillus.
And that would tell us which one was a good preventative measure for inhibiting the growth of the bacteria. The restaurants had the highest occurrence of bacteria, and we think it has a lot to do with the way they store it.
That they're left out and uncovered and under heat lamps.
We couldn't actually test for quantitative occurrences of the bacteria, but we did find out that there were traces, and that's why it grew. Now, as far as making a person sick, it just depends on person to person. Older people and younger people are more susceptible. It depends on your immune system. It also depends on how much is actually in the food.
My project is over the properties of light and color and how when you alter the light source, what you perceive can be altered, the color off of that object's chemical makeup. I took spectrometer readings and showing the different wavelengths, the major bars of the spectrum that stand out within each light. And I did everything in a controlled environment. I used color filters to shine through a box on a test sheet with 6 major colors on it, and that was my constant. And when I looked at it, it made it like a totally different color. And by doing that, me and my dad both looked at it, and he saw a totally different color than me. So like on a yellow filter, on yellow surface, I saw a bright yellow, and he saw like a dark gold. So to me, maybe that means that, you know, maybe what you perceive as blue might be what I perceive as red or yellow.
I won the first place in the Behavioral and Social Sciences category with my project Effects of Contrast and Luminance on Magnocellular Defined Boundaries, which is basically a beginning study into how the visual system works and how we can find ways around the visual system. Once we find out how this visual system works, we can eventually go on to build computer programs to mimic it. And once we have computer programs with visual processing capability, we can pair that with artificial intelligence and build something sort of along the lines of smart cameras. Anything with an input device that uses vision can recognize things such as security cameras. Artificial eyes are not out of the possibility. Once we figure out how the brain works, we can mimic the function with electrical devices. And all that might seem really far off in the future, but this project is really just part of the basic knowledge of how the eye works and how the eye transmits knowledge to the brain, and how the transmittance of that information, the light, how changing values of brightness and contrast and luminance can make your brain see something that's not really there. What I do is I wrote a program to isolate a specific system in the visual cortex called the magnocellular system, which functions on a wireframe basis. It basically takes light and dark, like this black and white, and draws a line for you. Wherever there's high contrast, it tells you there's an edge. So I took this is the magnospecific stimulus. I take these two screens and flicker them rapidly. That's the stimulus that shows you the magnocellular system. I modified that with my program where one pair of luminances were flashed on the top and another pair of brightnesses was flashed on the bottom. And basically, I altered the values of the bottom brightnesses in order to try to copy the top brightnesses. But I did this by changing the mean luminance and decreasing the percent contrast. And once I did that, as you can see, the percent correct dropped dramatically in most of my subjects. So it becomes possible where one system of your brain, one of the visual processing systems, begins to take on the role of another. The magnocellular becomes, or takes on part of the parvocellular, which is the surface-oriented pathway. It lets you see luminances and colors where it's not supposed to. So this is somewhat of a breakthrough in that traditionally it used to be cut and dried, magnocellular here, parvocellular here, but now we see magnocellular beginning to take over some of parvo's functions.